Hello students, welcome to the new lecture. In this lecture, we'll discuss the fill in the blanks questions of time domain analysis or first order RLRC circuit BW unit number 1. So this is the fifth lecture in basic electrical engineering JNTH affiliated colleges first year, first mid previous year questions and solutions. This is the last lecture in unit number 1. It's about the transient analysis fill in the blanks questions. Already we have completed multiple choice questions of transient analysis or time domain analysis. Now we'll discuss the fill in the blanks questions. Let us start with the first question. Capacitor does not allow sudden changes of what? So you know capacitor has a property, it does not allow sudden changes in voltage. So the answer is what? Voltage. And the second question, the capacitor at steady state acts as dash. So we know the capacitor current formula, I is equal to C dV by dt, and here steady state means let us substitute dt is equal to infinite. So C into dV by infinite, something by infinite is equal to what? 0. So current 0 means at capacitor, at steady state capacitor acts as a open circuit. So capacitor is acting like a open circuit at steady state condition. And this is one way of analyzing the answer. And one more way is, we all know at steady state voltage across the capacitor becomes constant. Voltage across the capacitor becomes constant means V is equals to constant. V is equal to constant. So now I is equal to C d by dt of V. Now this V is a constant value. So d by dt of constant. Differentiation of constant is what? 0. C into 0. So current 0 means again what? Open circuit. At steady state, there is no change in the voltage and current through the capacitor becomes what? 0. Current 0 means what? Open circuit. Third question, the time constant of series RL circuit is. So for time constant of RL series circuit is what? L by R. We denote the time constant with the tau. Fourth question, when a series RL circuit is connected to a voltage source V at t is equal to 0, then what is the current passing through the inductor at t is equal to 0 plus? At t is equal to 0, the voltage source is connected. After that instant, at t is equal to 0 plus, after switching operation, immediately after switching operation, what is the current through the inductor we need to find. So let us say this is a power supply and this power supply voltage V. Initially the switch was in the open condition. At t is equal to 0, the switch is going to be closed. This is the R and this is the L, and at t is equal to 0 the switch is going to be closed. At t is equal to 0 switch is closed means power supply V is connected. Then what is the current flowing through the inductor? IL of 0 plus we need to find out. So as initial conditions are not mentioned, that means before switching operation, do we have any charging in the inductor? Do we have any current in the inductor? It is not mentioned means we have to take before switching operation, before the power supply is connected, current through the inductor IL of 0 minus is equal to 0. And we know inductor has a property, it does not allow sudden changes in current. That means after switching operation also, current through the inductor is going to be 0. After this switch is closed, at t is equal to 0, the switch is going to be closed. Now current through the inductor becomes what? IL of 0 plus. Before switching operation is current is equal to 0 means after switching operation also current through the inductor is 0. After switching operation also current through the inductor becomes what? 0. So the answer is what? 0. Next, question number 5. Laplace transform analysis gives a dash and dash responses. Laplace transform will give us time and frequency responses. It will give us time and frequency responses. Next, sixth question. The Laplace transform of unit step function. Laplace transform of unit step function is 1 by s. Next, the transform inductance for inductor is given as impedance of the inductor in S domain is what? Ls. Transform inductance for inductor is what? Ls. Next, eighth question. With some initial charge at t is equal to 0 plus, capacitor will act as what? So that means before switching operation, some voltage across capacitor is some V. Let us say it is some V naught. Before switching operation, the capacitor already has some charge and its voltage is V naught. Then here it is asked, what is a VC of 0 plus? After switching operation, at t is equal to 0 means after switching operation, VC of 0 plus equal to how much? We know capacitor does not allow sudden changes in voltage. If before switching operation, if the voltage is V naught, and after switching operation also the voltage is going to be what? V naught. That means after switching operation at t is equal to 0 plus, there is some voltage in the capacitor, that is V naught. That V naught we need to represent now. Some voltage V naught will represent as a voltage source. With voltage V naught. So with some initial conditions at t is equal to 0 plus, a capacitor will act as voltage source. Okay. So these are the few fill in the blanks. So with this we have completed unit number 1. So unit number 1, multiple choice questions and fill in the blanks of last previous year JNT previous year first mid questions and solutions. Unit 1 is completed. In the next lecture we'll start with the unit number 2, that is about the AC circuits, multiple choice questions and fill in the blanks, previous year questions and solutions will start. Thank you.